going to go over number 8 with you.
So for number 8, it was g of x minus the f of x. So I plugged them both in. So I got 5x to the 1/3 plus 4x to the 1/2 minus 3x, or negative 3x to the 1/3 plus 4x to the 1/2. And so I first distributed the negative 1 to the minus. So then it's plus 3x to the 1/3 minus 4x to the 1/2. And so the 3, 5 add together, so it's ax to the 1/3, and the 4's cancel out. And the domain is 0 to positive infinity, because the other two equations have the same domain.
Any questions with 8? So the key thing, you were asked to do the domain for all of those problems. So not only were you just like evaluating, finding the operations, but you're asked to do the domain. Even though his answer says 8x to the 1/3, the domain is based off of the original 2 functions that you're starting with, not the answer. So his answer's domain might be different than what the original functions that you started with. But it's based off the original functions because you could be evaluating from those original functions to get the answer. So make sure you've got that domain from 0, including 0, to positive infinity. Okay, that's right. So Grace has number 17.
Okay. So, 7. Alright, so it was the g of x and then f of x, g of x divided by f of x. So you'd put 5x over 5x with the 1/2 over 4x and 2/3. So then you'd have to find, whenever you divide, you'd have to find the common denominator because you subtract the two exponents. So you have to multiply the 1/2 by 3, and then the 2/3 by 2, and then you'd subtract 3 over 6 by 4 over 6, and since the x would go with the 4, and the 1 would go with the 6. So then, if you would switch it around, it would be 6 square roots of x, and since you can't have any negatives in the denominator, it would be 0 to infinity. So, yeah.
So those last couple of problems with the fractions, you can't just leave your answer with those x's when you're using those powers and the properties. If you both have x, or if there are 2 x's in the problem, they can be combined. So addition, you can't combine them, but division you can, because the power or the rules of exponents say you subtract the exponents to combine the x's. So this is not your answer. Like, it's not just boom, you're going to write it as division, there's nothing left to do. Because you have x's, my 1/2 minus 2/3, she converted that to 3, 6, and 4, 6. You're subtracting those powers to simplify it. So this is for like the last 3 problems, I think 16, 17, 18, 19 maybe. That last handful of problems they had to do. So subtracting them, she got a negative. Because it's negative, the x is in the denominator. The 5/4, you don't do anything with that because you can't reduce 5/4. So the 5 has to stay on the top, the 4 is on the bottom because that's where they were originally. But then that x goes in the denominator because when you're subtracting, it's negative. So a negative has to be in the denominator. And then she has parentheses around that 0 because, again, 0 is in the denominator. Or, I'm sorry, x is in the denominator, and you can't have 0 in the denominator. That's why you get some parentheses. Questions? Nice job. So if you could see if you can work on that 3rd sheet of paper, finding the domains.
I thought I was done. Oh, sorry. Miss Kane, I didn't know everything about World War I. Like, not just like what some stuff, like just
Oh,
World
did
War
you
I.
feel like you learned a lot then?
What was the bloodiest battle?
The Somme, the Battle of Somme. Yeah, Ryan, I did my homework. I mean, well, actually.
No, you didn't.
No.
It's
It's 87 questions.
Super quick. It was like the easiest game. Yeah, just a few. There's like
What are you on right now?
Just finished World War I.
It's amazing.
Are you into Weiss?
Yeah, we did.
Yeah, then you guys did forever in World War II, so Miguel Hawk. I don't know how you guys did so fast. Did you do all the battles?
No.
The Somme, the Verdun,
So you have
We did,
answers
yeah, we were done,
Yeah.
It was a big video. How is that relevant at all?
Those were all battles.
You and
Thanks.
I'm just gonna point out.
Wait, turn around. Let me see the other side of your face.
Below Wood was. Ow!
Let me see the other side of your face. And you have something smudged there.
Okay, I just swear, how come
I don't think this is gonna help. Oh, it's 19.
Y'all, what'd you get for number 3? I got x is not equal to -3. So.
I said x has to be greater than or equal to negative. I said brass or -3
Anyone have questions on the homework?
Yeah. Did you get 0, comma?
Yeah.
Brass. Yeah, 0.
No, because so f of x is 4x to the 2/3. G of x is 5x to the 1/2. So 16. So Virginia asked about number 16. Yesterday when we were working through the problems in the notes, I had you list the domain of the functions first before we actually talked about getting the domain of the answer. So if you're looking at these two functions, this is really the cube root of x squared, and this is the square root of x. So cube roots have a domain of -infinity to +infinity because you're allowed to have any number underneath. When it's odd, you can put any number underneath the radical. You can have a negative, you can have a positive. But square roots have to be greater than or equal to 0, which means it would go from 0 to infinity. So the answer to number 16 would be 4x to the 1/6, that's supposed to be 1/6, over 5. So Virginia said your answer should be then from -infinity to +infinity? Is that what you said? Yeah. But it isn't because the domain is based off of the two functions, not the answer. So like your answer has nothing to do with the domain. It doesn't determine the domain, it doesn't find the domain. It's based off of your original two functions. And the reason it's based off of those two functions is because if you were asked to evaluate, sometimes you evaluate from the original function, like you would have to plug in a number for x. Well, if you were trying to plug in a -5 for x, you could plug it in here, but you can't plug a -5 into that other one. So it's based off of the original function, not the answer. So this domain would be from 0 to infinity because g of x's domain is from 0 to infinity. So when you're looking at the domain, like even if you get a whole number of 1, the domain is still from the original problems. So your answer doesn't derive the domain. It's the original two equations that are giving you the domain. Questions on that? So then if you look at the little third sheet of paper, without graphing, find the domain. So f of x is equal to x to the 1/2. How could you write x to the 1/2? Aaron? Square root of x. What's the domain of the square root of x?
0 and positive infinity.
And what goes around the 0?
Bracket.
A bracket. Any square root has to be greater than or equal to 0. So there's two things with domain that you have to remember. If it's a square root, it has to be greater than or equal to 0 because you can't have a negative underneath the square root. If it's a fraction, you can't have a 0 on the bottom. Otherwise, it's from negative infinity to positive infinity. So like there's really two cases that you've got to think about. So square roots have to be greater than or equal to 0. Since number 2 is exactly the same thing as number 1, it's just number 1 was written in the other form, it's also from 0 to infinity. And then number 3 says the square root of x plus 3. So Ethan, that is?
-3. Positive infinity.
Negative 3 to positive infinity, and what goes around the negative 3?
Bracket.
A bracket. So that one changes because now there's a plus 3 underneath. So that means you can have a couple of extra values in there before you get into that negative region. So if I had -4, then it wouldn't work because -4 plus 3 makes -1. But we can start at -3 and go to positive infinity. The last two here, these are kind of similar to each other. How would you rewrite x to the -1? Virginia? 1 over x. And we know x is in the denominator, it can't be 0. So how would you write the domain then, Virginia? Right, and then 0 to infinity. So in interval notation, this is how we say it can't be 0. It's allowed to be any other number from negative infinity to positive infinity, but it's not allowed to be 0. And by having parentheses around the 0, it means it can't be that number. So that's interval notation, how we write if a value can't exist. That's how we write it. So David, then for number 5, L of x equals x plus 4 over x minus 2. X can't be what? X can't be equal to 0, so therefore x isn't allowed to be the number 2. So the domain would be and, right, 2 to positive infinity. Questions? So today we're going to look at something called a composite function or a composition of functions. But like there's domain here of just an original function, kind of thinking about square roots and fractions. And then the problems you did last night, those domains are based off of the original functions. So there's going to be like 3 different things that we're going to try and look at. Composite functions domains are slightly different. So we'll talk about what to do to get those domains. In your packet, it should be on page 15. Yep.
Did you check the homework I missed?
I did check the homework. Yeah. So at the top of page 15, a composition of functions, or it's often referred to as a composite function, is just another way to try and combine functions together. This actually uses substitution to try and combine the functions instead of adding, subtracting, multiplying, and dividing, because those are the 4 operations. So if we can't add, subtract, multiply, or divide, well, we can use substitution from one function to the next. And that's what a composite function or a composition of functions does. So h of x is always our new function that we're creating. H of x can be found by taking the f function with the g function. I'll kind of explain what this is. So the last couple of problems of your homework look similar to this. The way we read this, you would say f, the outside letter, reading from the outside, working your way in. The first parenthesis is the word of, and then the second letter is g, and then the word of, and then my last variable is x. So when you're looking at it, you would read it as f of g of x. So what this means is that whatever's inside, your inside function, you're going to be substituting that into the outside function. So it's kind of substitution for one function into a second function. And you could actually do it for multiple functions, but we'll just focus on 2. The domain of these so first you have to find the domain of the inside. So you're going to find the domain of the inside function. In this case, it's g of x, but it isn't always g of x. So whatever's in the middle, in the inside of the parentheses, you're going to find that. Then you're going to find the domain of the answer. And remember, that's the answer or your solution, your final answer. Say final answer. So you're finding the domain of the inside, the one you're substituting. You're finding the domain of the answer. The overlap, then, is where your domain would be. So with operations, you're using the overlap of your initial two functions. With compositions, you're using the overlap of the middle and then of the answer. So they're slightly different in what you're looking at. So we're going to try and do a couple of problems. I'm skipping number 4. We're going to come back to it because I want to do the ones that have the numerical values in them, and then we'll do the ones that have the x's. It just makes a little more sense to do with a number first and work through some problems with numbers, and then try and work through them with variables. So the last part of the homework, I asked you to look at it. I asked you to just try and see if you could understand what was going on. And it was similar to number 3 here and number 5 on your page. So we have f of x equals 2x minus 7, g of x equals x squared plus 4. We're not finding the domain because we're actually evaluating for a number. There's not going to be an x left in the answer. So this problem says find the value of g of f of 3. So every parenthesis is the word of as you're working your way in. So if I'm finding a value, that means my answer is going to be a number if I'm finding a value. I'm just going to rewrite this over here. So we have g of f of 3. So when you're working with parentheses, where do you start with parentheses? On the inside. So that's what we're going to do. We're going to start on the inside. So whatever's on the inside, we're going to try and work with that piece on the inside, which is just f of 3. So I'm going to pull that apart and just separate it and try and think, what do I need to do to find f of 3? So we did this last week when we were starting to review for domains. Sarah, what do we do for f of 3? Yeah, you plug in 3 for x. Whatever's in the parentheses, inside the parentheses, that's x. The outside says the function to use. So we're using function f, which is 2 times x, that's now 3, and then minus 7. So you're taking the number, you're plugging it into the function. Sarah, 6 minus 7 is? Negative 1. So here's where the substitution part comes in. So we now did the inside of the parentheses. We're going to take this answer and substitute it in place of the f of 3. Because I just found that number. So in the problem, we have a g outside. We found this to be negative 1. So we're going to take it and replace it with the number negative 1. That's what substitution says. If you find something that is equal to a value, you could take it out and replace it with that number. So now we're going to do a second time, but we have to use the g function. So making sure you're using both equations here. So g is x squared, well that's negative 1 squared, plus 4. Is that what happens when you square negative 1?
You get 1.
And 1 plus 4 is?
5.
So the value of g of f of 3 is 5. That would be my final answer. So we use the inside, and then we go to the outside. So you're doing substitution kind of like twice, but you're making sure you're using both of those functions. So we're going to skip 4, because number 5 are a couple examples kind of working with this. I think there's 3 examples down there. So if you skip number 4, look at number 5. Just 2 different equations to work with. So f of x is 3x minus 8. G of x is 2x squared. And we want to find g of f of 5, and then flipping it, f of g of 5. And then the last one, you're trying to plug the same function back into itself. But always start in the middle. So we're starting with f of 5. So you're picking the f function, that's 3x minus 8. Instead of x, we have a 5. So page, this would give us 7. So then that 7 is going to replace f of 5. So now we have g of 7. As we just found f of 5, we found this number here to be 7. So the g function says take 2 times 7 squared. So Jenna, 7 squared is? And 2 times 49 is? 98. So g of f of 5 is 98. So letter B just flips it. So if you look, the inside now says g of 5, so it's just the opposite. So kind of saying like what happens, should you get the same answer or you're going to get a different answer? So starting on the inside, we're starting with g of 5. So Ethan, 5 squared is?
25.
2 times 25 is? 50. So you're taking 50 and plugging that in. So now I have f of 50. So f said 3 times x, well x is 50, and then minus 8. So Ryan, 3 times 50 is? 150 minus 8 is 142. So the last one wants you to use f of 5, which we already found to be 7 from letter A. We said f of 5 was 7. What are you supposed to do with that? Sarah? Yeah, you're going to re-plug that back in. So you're using f for a second time, now with the number 7, the value you just found. So that would be 3 times 7 minus 8. And Sarah, 21 minus 8 is? 13. Questions? They're kind of like little puzzles in a way. You're kind of putting the pieces of the puzzle together. Alright, so we're going to go back up to the variable problems now that we skipped over. So go back to number 4 in the middle of your page. Before we do anything with the variable problems, we're going to talk about the domain. So looking at the functions, what are the domains of the functions? Because that helps us get the domain for the answer as well. So the first function, if we have 4x to the negative 1, Sarah, can you just tell me how you'd rewrite 4x to the negative 1?
It would be 1 over
Close. H?
4 over x.
Yeah, so these separate. The 4 is not attached to the x to the negative 1. So whatever has the negative moves down. If it doesn't have the negative, it has to stay. So this currently is really on the top, so it would be 4, and then x is on the bottom. So they're not attached together unless there's parentheses attaching them together. Otherwise, they can split and separate. So if we have 4 over x, what would that domain be? X is now in the denominator. Paige?
Negative infinity to 0, and then 0 to positive.
Right. So if you have x in the denominator, from the warm-up, we said it can't equal 0. So that means it's not allowed to be 0. When we're writing the interval notation, you get parentheses around that. How about the second one, just 5x minus 2? What's the domain of the second one, Paige?
Negative infinity to positive infinity.
Yeah, so this one is negative infinity to positive infinity. So we will use that and help us apply it to find the domain of the answer. So this problem is done very similarly, except we don't have numbers to plug in. So we're going to have to be keeping the x's in the problem. But we're going to start the same way. We're going to start in the middle. So it says find f of g of x. So in the middle is g of x. Well, what is g of x? Sarah, what's g of x? 5x minus 2. So I'm going to keep the f, but using substitution, instead of g of x, we have 5x minus 2. Because that's what g of x is. So now the next part is to use the outside function. The outside function says 4 over x. I'm going to keep it in the fractional form. So there's a 4 over x. But instead of x, what are we supposed to replace x with? Ethan? 5x minus 2. Because whatever's here has to replace x. That's the substitution part. So now I had the 4 divided by x, but x is now 5x minus 2 from the other equation. So this is our new function here. Can that be reduced? No. Are all of them divisible by 2? No, I can't divide 5 by 2, so it can't reduce. So here's our solution. That's f of g of x. Questions with that? So now we have to get the domain. So the inside domain was negative infinity to positive infinity. So it can be all of those numbers. However, my answer also determines the domain. So what would have to be restricted from the answer that we have here? What can't you have in the denominator? Sarah? You cannot have, she said, 2/5. So x can't equal 0. Whatever's in the denominator isn't allowed to be 0. So if you add the 2 and divide by 5, that means x cannot be 2/5. So it's allowed to be anything, negative infinity to positive infinity, but the number 2/5. So that means it could go from negative infinity to 2/5.
Wait, why can't we?
Why can't it be
Yeah.
2/5? Because you have a fraction, and in the denominator of a fraction, it cannot be 0. So if you solve this little equation down here, Sam, how would you solve it?
You would divide both sides by 2. Add 2.
So we would add 2,
Okay.
and then divide by 5. So 2/5 is the number that makes it 0. So if we plugged in 2/5, we would get a 0, and that's not allowed to happen.
Is that the domain you write 2/5 to 0?
I did. Thanks.
Okay.
Thanks. Yeah.
So you base the domain of the answer off of the first two you started with, so why did you base it off?
You base it off of the inside one that you started with, not both of them. So you base it off of the inside and your new function. So we started with the inside of 5x minus 2 and my new function of the fraction. Other questions? So if you look at letter B, we have g of f of x, so kind of just doing the opposite, flipping it around. So start on the inside. I'm going to write it as that fraction, 4 over x. So f of x is the equation 4 over x. And then you're applying that to g. Well, g says 5 times x minus 2. So typically I would write 5x minus 2. But instead of x, we're now using 4 over x. Because whatever is in the parentheses has to replace the x in your function. Can that be simplified? Aaron?
Break it into 20 over x minus 2.
Perfect. We can make it into 20 over x and then minus 2. Jen? Because if you write 5 as a fraction, what is 5 as a fraction?
5 over
5 over 1. So the 5 goes to the 4, the 1 goes to the x. Other questions? Anyone know what the domain is?
Will we catch up?
Sure, Sam.
Okay, so it would be negative infinity to, I don't know, it would be negative infinity to,
So look at the denominator. What can't the denominator be?
x, or wait,
Number. What number can it be?
negative, I don't know.
H? 0. It can't be 0. So the denominator is not allowed to equal 0. That's the only number that you plug in for x that makes it 0, because it's just an x down there. So it can't be 0. So negative infinity to 0, 0 to infinity. Questions?
Wait, so if you plug this into a calculator, it would graph it, but it would leave a skip out there.
It would skip out 0. So if we looked at that table of values, it would have the word error at the x value of 0. Alright, so I'm going to skip letter C and flip over. I want you to be able to like look at another set of functions. Alright, so just looking at another set of functions so you have a different set of examples to work with. Again, look at the original functions and think about the domain first. So if we have 6x squared, what's the domain of an even function?
Positive infinity, negative infinity.
Yep, negative infinity, positive infinity. And then the other one is an odd function because it's just 3x plus 1. That domain is also
Positive, negative infinity, positive.
negative infinity to positive infinity.
Do we say all real numbers anymore?
No. So we're going to, from now on, like till you're done taking math, which might be sometime in college, you'll say
Okay,
negative infinity to positive infinity. So if you look at the functions, inside is g of x. So Ethan, what's our g of x function?
It is 3x plus 1.
3x plus 5. We're going to apply that to the f function, and f says 6 and then x squared. Well, instead of x squared, we have 3x plus 5. Now, this can be simplified. There's something we can do with this to simplify it. Paige?
Can you distribute the
Distributing, we have to do whatever's in parentheses first, so following PEMDAS. So we're not going to distribute yet.
Well, the 2.
What does that 2 mean
Um,
with this?
you would square it.
Square it?
Yeah.
Or that there are 2 of them. That's what that 2 means. So if you FOIL that, Paige, what does that give you?
9x squared plus 15x.
Well, then they would cancel. And then plus
It would be from
It'd be 38.
So it would be 30x
Oh, yeah,
because they're both
30x.
positive. So 30x and then plus 25. Yeah. So make sure that when something's squared, it means they're double of that quantity. There are 2 of them that get FOILed together. And then if we distribute the 6 through, that gives us 54x squared, 180x, and 150. So we said the domain of g of x was negative infinity to positive infinity. What's the domain of the answer? Jason? Negative infinity to positive infinity. Because it's an even function still. All even functions, negative infinity to positive infinity. So look at the middle one. It's the flip. So we have g and then f of x. So here's my f of x. That's 6x squared. So you're taking that and putting it in for g. So g says 3 times x plus 5. So we've got g of 6x squared. So 6x squared needs to go in place of x. What would this be if we simplify it? Truth, are you raising your hand back there? What is 3 times 6, Truth? 18. And then plus 5. So Truth, if it's even, what's the domain of an even function? Yep, negative infinity to positive infinity. So try that last one. Got about 3 minutes. F of x. So you're taking f, you're plugging it back into f.
Thanks.
yes, anything.
Alright, so f of x is 6x squared. If you plug in f of x, be careful with this. You're plugging it into 6 and then x squared. So you're taking 6x squared in the parentheses. If you square this first, order of operations says you need to square that first. Squaring the 6 becomes 36, x to the 4th, and then you still have a 6 outside. 6 times 36 is 216. Nice, Ryan. Even functions, Ryan, have a domain of negative infinity to positive infinity. Nice job. Questions? So your homework on that worksheet, please make sure you're doing 1 to 17, and then 1 to 17 odd, and then 19 to 29, all of them. I'm collecting this tomorrow. Put it on a separate piece of paper. You must have the original problem. You must have work. If you don't have work, you're not getting any credit whatsoever. We're now at the second half. I'm going to be a little more picky with those easy homework points that you're getting. So you got to have work for credit. Make sure you've got work to support your answers. Yes.
Where